Now let's see this question. Consider a 16-bit register of the following format is used. Consider a 16-bit register of the following format is used to store a floating point number. Mantissa m is denoted as normalized sign magnitude fraction. Exponent e is expressed in XS64 form. Base of the system is 2. Then how many bits are allocated for the fractional mantissa? That is asked. So what they have given is, they are saying that there is 16-bit register which is used to represent floating point number, and they are saying that the mantissa is expressed as normalized sign magnitude form fraction. So now if we assume that this is bit used for sign, and this is the bits used for exponent, and this is the bits used for mantissa. Now they are saying that sign magnitude form is used, which means there is going to be sign bit. So 1 bit is going to be dedicated for that, and therefore remaining 15 bits have to be distributed between these two. But then they didn't give exactly how many bits are given for exponent and how many bits are given for mantissa. But one thing they gave is that they are using XS64. So XS64 is used. Now what does it mean if XS64 is used, right? So if we assume that k bits are going to be used for this, are dedicated for this, then how many bits will be dedicated for this? 15 minus k bits will be dedicated for mantissa, because total it is 16. 1 bit is taken out, and out of 15 I am distributing it this way. Now with k bits in the exponent field, what is the maximum negative number possible if you are going to use 2's complement number system? If nothing is given, assume that 2's complement number system is used to represent the exponent, right? Now what is the maximum negative number possible? Minus 2 power k minus 1, isn't it? So now in order to compensate it, we are going to use the bias. So what is the bias going to be? Plus 2 power k minus 1. Now they are saying that the bias here is 64, which means 2 power k minus 1 is going to be 64. Therefore 2 power k minus 1 is going to be 2 power 6, right? So which means k minus 1 is going to be 6, that implies k is going to be 7. So 7 bits are given to this, and out of 15, if 7 bits are given to this, then 8 bits will be given to the mantissa. So that is the answer for the first question. So how many bits are allocated for fractional mantissa? So how many? 8 bits is allocated for mantissa, and then 1 bit is for sign, and 7 bits is for exponent. Okay, fine. Now let's see the extension of the previous question. What is the expression for the decimal value? So they are asking us to find out the formula for the decimal value. Now we have found out that the representation is, for sign it is going to be 1 bit, and for exponent we got 7 bits, and for mantissa we got 8 bits, right? Now what is the expression for the decimal value, which means what is the formula that you are going to use in order to convert this representation into decimal number? So minus 1 power s into, now if nothing is given, generally we generally don't use explicit normalization, because implicit normalization can be used to represent more numbers, isn't it? So using the same representation, we can store more values in implicit compared to explicit. So that is why we are going to go for implicit only. So if nothing is given, take it as implicit. Now in implicit representation, we know that we are going to write it as 1.m, whatever is mantissa, I am going to write it there, into 2 power exponent. So what is the exponent? So e minus bias. So they already gave that the bias they are going to use is XS64. So which means 60 plus 64 is the bias, therefore you subtract it. So this is the formula which you should be using in order to get back the actual number. Alright? Okay. Now next one is, what is the value of the largest number that can be represented in base 10, which means what is the largest number that you can represent using this representation. So in order to find it out, what could be the largest number? If it is a positive number, then it could be the largest. So therefore sign is going to be 1, and exponent should be as large as possible, and mantissa should be as large as possible, which means I am going to get 1, 2, 3, 4, 5, 6, 7. If there are 7 ones, that is the largest exponent possible, isn't it? And what about mantissa? That too has to be as large as possible. So 1, 2, 3, 4, 5, 6, 7, 8. Correct? So now this is the largest number possible that can be represented using this 16 bits, right? Okay, now what is its value in base 10? That is what is asked. Now let's try to convert this value into base 10 by using this formula. It is going to be minus 1 power 0 into 1 point mantissa. Mantissa is 1, 2, 3, 4, 5, 6, 7, 8 into 2 power e minus 64. So what is e? E is 7 ones is given, right? So what is 7 ones? If you consider it as a positive number, unsigned number, 7 ones is nothing but 2 power 7 minus 1, which is 127. So it is 127 minus 63, right? Now just try to convert this entire number into base 10. So we know that. So let me convert this entire fraction to base 10 first, right? So what is this? 0.12345678. Now this one is 2 power minus 1, this one is 2 power minus 2, this one is 2 power minus 3, so on. The last one is 2 power minus 8, right? So it is nothing but 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus so on plus 1 by 2 power 8. Now how many terms are there? 8 terms are there, and the first one is 1 by 2. Therefore I can use this GP formula because all these numbers are in GP, geometric progression, right? So a into, what is a? First number, a into r power. So since r is less than 1, a into 1 minus r power n. So what is r here? This one. 1 by 2 power n means number of terms. Number of terms is 8 divided by 1 minus r. So what is the formula I used? A into 1 minus r power n divided by 1 minus r. So why 1 minus? Because r is less than 1. If r would have been greater than 1, then a into r power n minus 1 divided by r minus 1, right? Now this 1 by 2 and this 1 by 2 will get cancelled off. Then I am going to get 1 minus 1 by 2 power 8. Got it? So you can also remember it this way. If you have 0.123, 3 ones, then it is 1 minus 1 by 2 power 3. Using the same derivation you will get it, right? If I have 0, 1, 2, 3, 4, then it is 1 minus 1 by 2 power 4, right? You can remember it that way. Okay, so now what is the value of this? This is anyway going to be 1, and this entire thing I can write it as 1 plus 0.12345678, okay, into 2 power 64. I think here I had to write 63, right? X is 63, 64, therefore it is going to be 63. Okay, now what about this entire thing? See, did you understand this? 1 plus 1 point some fraction, I am writing it as 1 plus this. So anyway the answer is going to be same, right? Okay, now what is this entire thing in decimal? If you convert it to decimal, the value is going to be how much? 1 minus 1 plus 1 minus 2 power minus 8 into 2 power 63, right? So you can write it as 2 minus 2 power 8. So that equal to 2 minus 2 power minus 8 into 2 power 63. So it is going to be 2 power 63 minus, so what is the difference? 2 power 55, right? So this is the largest number that you can represent. Got it? So 2 power minus 8 and 2 power 63, right? So it is 2 power 64, right? So it is 2 power 64 minus 2 power 55. So this is the largest number you can represent. Okay, so now if you observe it, we are going to have actually two parts here. One is exponent and other is mantissa. Now exponent will give you the range. So as you increase the exponent, you can represent larger and larger numbers, isn't it? If you increase the number of fields in the exponent, you can increase, you can represent larger and larger numbers. Now this mantissa is going to give you the precision, which means how smaller numbers you can represent. So exponent, by increasing it, you will be able to increase the range, and by increasing the mantissa, you will be able to increase the accuracy. right? Which means you will be able to even represent a smaller number very accurately. If you have very less number of bits in Mantissa, then you will not be able to represent very small numbers to a very highest degree of accuracy. Got it? Okay, fine. Now the next linked question is, what is the 16-bit pattern for minus 7.5 base 10? So you have to find out what is the 7.5 going to be. So 7 is going to be 1, 1, 1 and 5 is going to be 0.1, right? Now you have to write it as base 10, right? And minus is there. So now how to represent it using the format that we have followed here is, the first one is going to be sign bit and the next one is going to be exponent. That is the normal format we follow, right? So exponent and next one is mantissa. So sign bit is going to be 1 and exponent we know is 7 and mantissa we got is 8. Okay, now if you see this is not in any implicit representation, so try to move this radix point so that it will be convenient for us to represent it in implicit form. See, nothing is given, we are going for implicit always. Okay, so what is it? It is going to be 1 point, I think this is base 2, right? So 1.111 into, since we have decreased the number, see, whenever you are moving this to the left side, we are decreasing the number, right? So increase it by 2, right? So this is the number we have to represent. Now what is going to be sign? Sign is going to be, since it is a negative number, sign is going to be 1, and what is going to be exponent? Exponent is actually 2, but then we are following the convention of excess 64, right? Which means it is going to be 64 plus 2, which is 66. Now we have to convert this 66 to binary and we have to place it there, right? So using 7 bits, it is going to be 1 0 0 0 1 2 3 4, right? 5 6, so 64 plus 2 is 66, right? So it is going to be 64 and it is going to be 2, so it is going to be 66. And what about mantissa? Whatever the remaining part is going to be mantissa, right? So 1 1 1, but then how many bits we need? 8 bits. So 1 1 1 you place it here, and then 1 2 3 4 5 you place it here, right? So now if you try to convert it back, you are going to write it as, what is the formula that we have used? Minus 1 power s into 1 point m into 2 power e minus 64. So this is the formula that we are going to use, right? Basis 2. Now if you observe it, minus 1 power s, that is why I am going to get minus sign here. Minus 1 power s is going to be minus 1, so it is going to be multiplied by this, and m is going to be 1 1 1 followed by all zeros, therefore it is going to be 1 followed by 3 ones, and 2 power exponent. So exponent is going to be 64. 64 minus 66. 64 minus 66 minus 64 is going to be 2. So again I'll get back the same number. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. university shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.